All right, we're going to wrap up this section with probably the most important single piece of information from this section here. So here's the important conclusion for us. This is like the big summary of all that we've been talking about. If a function is known to be continuous, well, remember what it means to be continuous. To be continuous is to say that the function value exists and they are equal. The function value exists, the limit at that point exists, and that those two are equal to each other. So if those three things are true, then the function is continuous. The converse of that would be that if the function is continuous, then these three things have to be true. And what we just said in the last video is that essentially every function that you've ever thought about or talked about in a math class is continuous, which means that since you know that the function is continuous, then the following three things have to be true. The function value exists, the limit exists, and they are equal to each other, right? This is basically just restating our initial definition of continuity in reverse, right? At the top we said if these three things are true, the function is continuous. Now we're saying if we know the function is continuous, then these three things must be true. And now why is that a big deal? Well, that means that when we're trying to find limits, if we're trying to find a limit of a function that is known to be continuous, all we have to do is find the function value, and that will definitely be equal to the limit. In other words, if I want to find a limit on a continuous function, all I need to do is find the function value at that point. Or in other words, we can find the limit as x approaches c of f of x by simply plugging c into x, right? By plugging c into x, by substituting c into the function x, or into the function f of x. That's it. All we have to do is plug it in and find the function value. We call this method direct substitution, and it is our primary, most favorite method for finding limits from this moment forward for the rest of your math career. This will always be the default first instinct for finding a limit, and you'll hear me harp on that more in the next section when we develop further methods for finding limits. But if we know that a function is continuous, we can find its limit by simply substituting it directly in. I mentioned that in one of the section 3 videos about the limit laws, is that the limit laws basically feel like you're just stretching a function out into its simplest pieces, and then you just plug the limiting value in essentially because you're finding just pieces that have x in it. So you plug the limiting value into x. And now we're formally saying that yes, that's correct. All we need to do is substitute the value that x is going toward into the function to find the limit. Let's look at a couple examples. It says evaluate each limit using continuity. You might say that as using direct substitution. The sine function is known to be continuous. We know that sine is continuous everywhere. Sine is continuous for all real numbers. And since sine is continuous for all real numbers, that means we can just simply plug in x over 3. So the limit as x approaches pi over 3, I said x over 3, but pi over 3, of sine x is simply sine of pi over 3. So we're seeing again our need to remember all of our trig function values. So let's remember back to our trig chart. Sine of pi over 3, that's 60 degrees. Sine of 60 is the square root of 3 over 2. So we know that the limit as x approaches pi over 3 of sine x is the square root of 3 over 2. And finding limits just got as easy as simply substituting the value into the function and finding the function value. No tables, no limit laws, and so on. So right, while we're in this chapter, we're still gonna, I'm still gonna ask you or have questions where I ask you to find a limit using a table or ask you to do a limit using the limit laws, just to practice those techniques, because they're always going to need to be there as fallbacks, because we're going to focus on functions that this doesn't work for as well. But for now, our first instinct can always be, let's just plug it in and see what we get. And you'll practice this a bunch on the homework. So here we want the limit as x approaches -1 of 3 to the x over the square root of x plus 5. It's worth pointing out that both of these functions are continuous and continuous at -1, which is what's important. And so we can just go ahead and do substitution here. To find the limit, we can plug in -1 and simplify from there. 3 to the -1 is 1/3. Over -1 plus 5 is 4. The square root of 4 is 2. So we have 1/3 divided by 2, which is 1/6. So we know that the limit as x approaches -1 of 3 to the x over the square root of x plus 5 is 1/6. Okay, so this is really great news. If we know that a function is continuous, we can find the limit by direct substitution. Just plug the value straight into the function, and this will be our first instinct from here on for the rest of your math career. Again, I will say there's exceptions within this chapter in that I will specifically say find this limit making a table or so on, just to get you practicing that technique and so you can show me that you know how to do that. Because, again, this is great when the function is continuous, but we will run into issues where we have functions that are not continuous. And in fact, that's going to be their main point of emphasis the rest of the chapter is, all right, this is really great and wonderful that for the majority of functions at the overwhelming majority of x values, we can just do substitution to find a limit. Well, that actually makes finding limits very mundane because you already know how to substitute values into functions. That's not that interesting. So we're going to focus on the points or the x values where substitution doesn't work. So this is our first instinct for the rest of our math career, but in the rest of the chapter we're going to focus on, well, what happens when we can't do that. But for now, for homework tonight, practice more with continuity, recognizing discontinuities, and specifically practice using direct substitution to evaluate limits. Okay, and that's your homework here for section 4.